Hi guys, my name is Gwen from EveCom Quantum Systems in Singapore. Today we are going on a continuation. This is chapter 6 where we are speaking about quantum search algorithms. So we've mastered exponential speedups for structured problems. But what about the messy world? What about unstructured search? Finding a needle in a haystack. That is actually the domain of Grover's algorithm. And it's a fascinating field, and it doesn't give us just the exponential win of shores, but it gives us a quadratic speed up for everything. What does this really mean? Let's start with the Grover iteration. So, the problem is simple. You find, or to find a unique item in a database of n items, you check them one by one, right? Grover's algorithm changes the game by using Grover iteration. And this isn't a random search, it's a geometric rotation. So we start with a superposition of all possible states. And with every iteration, we rotate our state vector closer and closer to the solution. And so this iteration is actually called a two-step dance. First, the oracle marks the correct answer by flipping its face. Second, the diffusion operator performs an inversion without the average, so it pumps amplitude into that marked state and it kind of like sucks amplitude out of the wrong one. So it kind of like is a maximizer normalizer. So we repeat this pi over 4 times the square root of n times, and suddenly the correct answer is the only one left standing. It's kind of like it amps up the good stuff and then decreases the bad stuff, right? So in quantum counting, Grover's is an amazing search tool, but it's also a counter. So if you combine the Grover iteration with a QPE circuit from chapter 5, we can actually count how many needles are in the haystack. It's a perfect example of composing our quantum tools to build new, more complex machinery, right? So we've covered the speedups now. We've covered the engines and the search hammers. We kind of have most of the elements in place. We've defined the rules of the game, but we've assumed the computer now is perfect. So what happens when the world gets noisy? In chapter 7, we'll move from perfect computation to quantum information theory, the study of limits from start to end, and the beginning of our quest to protect our information.